Right. So I want to we've talked down this left-hand column. More photons would cause more electrons to get ejected. But if the frequency isn't high enough, it doesn't matter how many photons you fire at that material. Those individual photons are not powerful enough to knock off an electron. And one time somebody said, like, is this kind of like a gun? Are these like light guns? Is a flashlight like a light gun? I guess it sounds violent, but yeah, a flashlight's kind of like a light gun. And if you were to take like a little BB gun, imagine this. You guys ever use a BB gun or seen a BB gun? They're little metal pellets. They're not bullets. They're little metal pellets. And if you fired little metal pellets at, let's just say, Lego. Can you imagine little metal pellets, tiny little beads firing at Lego? Can you imagine that I could shoot those metal pellets at the Lego and not break off any Lego? The Lego wouldn't break off. The Lego is the electrons, okay? It wouldn't break off, wouldn't fly away. And I could get a machine gun style BB gun. And if I fired like 1,000 rounds per minute of BBs, it still wouldn't knock off the Lego. Because it doesn't matter how fast or how many BBs, if the BBs can only land one at a time. They can only hit the material one at a time. And if one BB isn't going to knock off a piece of Lego, then neither is the next one, and neither is the next one, no matter how fast I fire them at them. You know, if we assume that loosening isn't a thing, right? Loosening the Lego pieces. And then people say, well, what would you have to do? Well, you'd have to get a more powerful gun. Maybe an air rifle, something you go play paintball with. And would you believe that a single paintball pellet would knock off a piece of Lego? Because it's more energetic or less energetic? More. And then once I realize, all I need to get is a more powerful gun, recognize that a more powerful light gun means a light gun, a flashlight, that can shoot light with a higher frequency. So now that we have a more powerful light gun, all I need to do is shine a little bit of more powerful photons, higher frequency photons, and electrons will get ejected. And if I go sideways on this, and once I've achieved photo ejection or electron ejection because of my more powerful gun, yeah, sure, I can crank up the intensity. I can pick up a machine gun, 2 flashlights, that fires photons at a higher rate, and I'll knock off more electrons. But I have to have first jumped the threshold to having a powerful enough light gun. And in this case, a powerful enough light gun, like jumping from BB gun to air rifle, means going from having low frequency light to high frequency light. And so this is something that was being figured out around the turn of the last century, was that photons don't follow just basic kinematics rules. Photons also follow light rules, where higher frequency means more energy per individual photon. And since only one photon can land per second, or at a moment, one photon can land at a particular location in space at a particular time. They don't land at the same time. Simultaneity of photon landings isn't going to happen for you. Just like if I fire a BB gun, you're never going to get 2 BBs to hit the Lego structure at exactly the same moment. You have to have one photon be capable of knocking off the electron. They can't team up. Have I sold this idea? And I hate to use a gun as my analogy, because it is like, a weapons thing. I don't want to make things violent. I don't want to like trigger anybody or anything, but it is a projectile issue, right? And these are photons, and I think that it fits the model nicely, that we need to sort of think about this as a high energy projectile, these photons. And that's not even a perfect analogy, because of light, of course, light has particle wave duality. So in one moment, I'm thinking about light like a bullet, and in the next moment, I'm talking about it like a wave. So this particle wave duality thing about light is something I'm dancing on either side of. And people say, is light a particle, or is light a wave? Well, it's not really either. And so people start to come up with silly sounding words like light is a wavicle, because it's not one, it's not the other, but it has properties of both.